A note is that mitosis is normal cell division. Last Thursday we started talking about, we built up to today, that basically in the human body, some cells are designed to undergo mitosis, while others are not. And cell reproduction in the body is a highly regulated system. When we say something's highly regulated, what's that mean? What's it mean for something to be regulated? Bless you. Well, like cars are regulated on the road. There's regulations about what they can do. You have speed limits, right? They're allowed to drive a certain speed. They're not allowed to drive faster than that, right? If your body was reproducing cells at too much a rate, your body would continue to grow. It would continue to expand, which isn't what it wants to do. And at the same time, if it wasn't producing them fast enough, you'd be losing tissue mass, right? So it's highly regulated, and we remember why. For growth, repair, and replacement, right? This is the basic reasons that we undergo mitosis. Cancer is a category of diseases. You can have cancer of the liver, you can have cancer of the kidneys, you can have cancer of the lungs, blood cancer, bone cancer. But what they all have in common is that in each case, cancer is just what happens when cells begin reproducing at an accelerated rate. Cells that shouldn't be reproducing begin reproducing, or cells that should be reproducing begin reproducing at too fast a rate. Cancer happens when cells in the body begin to reproduce in an uncontrolled manner. And cancer cells quickly move from interphase to mitosis. And the result is what we would say is rapid growth. Sorry about that. I just wanted to look ahead. What causes this? What causes this unexpected cell growth? Sorry, getting my timing here. Is damage to cells, DNA, can result in unexpected growth. Right? Remember, the DNA isn't just the blueprint for the cell, it's also the regulatory mechanism of the cell. It also is the instruction sheet for how to run a cell. And damage to the cell's DNA can result in the mechanisms for reproduction being turned on when they shouldn't be. What might cause that to happen? This can be caused by a number of things. UV radiation or other radiation. UV radiation is the most common sort of cancer-causing radiation, but obviously if you worked with high-energy radiation, if you, for example, you ever had to get an X-ray? I always think, you ever have to go get like an X-ray at the dentist, and they put that like leather vest on you? Not leather vest, the like lead. That's what I'm looking for. Put that lead vest on you, and they're like, here, like, we want to make sure the X-rays don't get into like your body. And I'm always thinking, what about my brain? It's good that you're like covering my chest with this, but what about my brain? But X-rays are a form of high energy radiation, so our exposure to them has to be very limited. Don't get me wrong, if you need an X-ray, you need an X-ray, get one, right? Check for bone and things like that. But you don't want to be exposed to that frequently. The people who do X-rays, that not have one taken of them, but the people whose job it is to actually operate the machinery and take them, take very serious safety precautions to make sure that they're not being dosed, regularly dosed with X-ray radiation, because that would be cancer-causing. If you work in a nuclear power plant, it'd be important for you to know that there's no leak of radiation, because if there were, that can cause cancer. Has everyone heard of the Chernobyl incident? The only uncontrolled sort of nuclear meltdown that we've had, and the people who worked in there for just a matter of minutes, across the board developed serious cancers and died. And people who lived in the surrounding town had extremely elevated cancer rates because that radiation is just extremely dangerous. There's some scary stuff where if you watch some of the film footage of when they were cleaning up the Chernobyl incident, you'll see various times where on the film there's just little flashes of white light, and that's literally high energy radiation striking the film that they were using to shoot on and causing it to expose, which is pretty crazy stuff. Yes, ma'am?
Are you doing something like really important right now?
I mean, I'm always doing something really important.
Well,
what do you need?
Can I take someone to take pictures for my tech class?
How long are we looking at?
Like 5 minutes.
As long as they don't mind getting caught up, yeah, absolutely.
Okay.
Perfect. So now, radiation can be a cause. What else can cause cancers? Various chemicals. So chemical exposure. Right? They don't put asbestos in buildings anymore because it's carcinogenic. Alcohol is carcinogenic. Nicotine is carcinogenic. What else? All kinds of things. Regulators require things to be labeled if they contain carcinogens. Do you know who the absolute leader on this is? Do you ever read the label when you buy something? You'll see one place come up and up again. You'll say, this product contains chemicals known by blank this place to cause cancer. California. California is like the world leader, and they require places to do very strict testing of what chemicals can be cancer-causing and write on the label. And we should all be thankful for them, because their regulations are stricter than just about anybody's regulations, but because it's such a big, rich state, people want to sell their products there. So if they want to sell their products there, they have to do that safety testing that other places aren't making them do. So California kind of helps us all out with that, which is kind. Chemical exposure can cause cancer. What else? Yep, that's a chemical exposure for sure, but I'm still going to put that for sure. Lifestyle choices. Because that's true, right? Like those lifestyle choices may be a part of this. Smoking is a huge cause of cancer. My dad smoked his whole life. My dad is currently a stage 4 lung cancer patient. And my every one of his friends smoked. And like the number of them who have had or have died of lung cancer is staggering. It's not a joke, right? These lifestyle choices make an enormous difference. By the way, nicotine is nicotine, and vaping is a little bit better for you, but it's still a massive carcinogen that you're pumping into your lungs. So don't do it. It's stupid. Um, Alcohol, cancer causing. Also, back to this UV radiation, sun tanning. Especially, listen, if you have darker skin, if your heritage comes from places that are equatorial, and your skin has a lot of melanin in it, that is a natural defense against UV radiation that the body developed for people who evolved to live in places where they're exposed to a lot of direct sunlight. The sun can still be dangerous, to be clear. Even if you have dark skin, you can still get skin cancers. But the darker your skin, the lower your skin cancer rates at a pretty serious way. If your family, so my family is half Italian, and those Mediterranean, that skin that has like a bit of an olivey complexion to it, I don't burn very easily. They have lower skin cancer rates. The other half of my family come from the UK. England, Ireland, Scotland, where the sun never shines, and they're all pale. They're all freaking pale. They have no pigment whatsoever. That side of the family, they burn instantly. Their skin is like tissue paper. If you have skin like tissue paper, don't tan. And by the way, it doesn't make a difference if the UV radiation comes from the sun or a bed that you've paid money to lie in and then be zapped with radiation. It is equally cancer-causing. Right? So wear sun lotion and don't tan, for God's sakes. Yes?
Not just X-rays or sunlight, but UV flash.
Yeah, you got to be careful. It's not something you want to be shining at yourself all the time. Now, I should say, good high-quality UV lights and equipment have been tested to, like if you have a black light in your room or something, that has been designed to be on the safe side of the spectrum that isn't damaging. But if you buy cheap stuff that may not be very well made, there's no guarantee that they've done that safety testing. So you should look up it should have an IEEE rating on it. In other words, it should be rated for use in like the US and Canada and have safety testing on it. Because if you just buy cheap UV bulbs and plug them in, you could be blasting yourself with damaging radiation. Absolutely. Yeah. Could be. Yeah, lots of chemicals are. And to be clear, the whole plastics industry is a real problem. We had a tremendously safe set of materials to put things in, which is like aluminum cans and glass bottles, very safe. Glass is so stable that it just basically doesn't react with anything. It just stays there. You can use a glass bottle 1,000,000 times, and it's still just a glass bottle. And when it starts to get crummy, you can melt it down, and then you know what you can turn it into? A glass bottle. Right? You melt it, turn it right back into a new glass bottle. Aluminum. You can recycle aluminum. You take an aluminum can, you can melt it down and turn it back into an aluminum can. And 1,000 years from now, you know what that can be? An aluminum can. It is like infinitely recyclable. They're pretty safe, especially glass. It just doesn't, there's nothing to leach off into our body. Glass is a big network solid of silica, so silicon, just stuck to itself covalently, and it's hyper stable. It's just super stable. But do you know why everything's in plastics? Why do we make plastic containers like crazy? Do you know why? Kind of. Do you know why it's cheaper? Because glass, interestingly, you know how you make glass? You go to a place that there's sand, you scoop up the sand, you go put that in a furnace, you let it melt, and then you pour it into a mold and you got it. That's it. Now you have glass. Plastics, where do they come from? They're hydrocarbons. You have to dig down in the ground and get fossil fuels out. So this plastic here, a few months earlier would have been part of the primordial sludge that comes out of the ground in like an oil refinery or in an oil field in Alberta or Texas or Saudi Arabia or whatever. And when they pull that crap out of the ground, they start distilling it off into its different parts, and some of it becomes gasoline, some of it becomes jet fuel, and some of it becomes whatever. And then you've got all this stuff left over, the heavier stuff. And what do you do with it? And the answer is they turn it into plastics. So part of the reason we're so tied to plastics is as we use more and more gas and jet fuel and things like that for energy, we get more and more of the other stuff left over. And what do you do with it? Well, we turn it into plastics and we sell it out and then we turn that in. But like, they're often low grade. They are non-biodegradable, right? So they're an environmental disaster. And they are not big stable compounds, so they leach things into whatever you store in them. And the cheaper the plastic, the more stuff they're leaching in. Yeah.
Aren't most not microwave safe plastic containers because of the chemicals they release?
Yes, exactly. Yeah, and take that seriously. If you're going to microwave something, do it on like a plate or in a glass bowl. Especially if you're like my house. I don't buy expensive Tupperware because my kids just lose it immediately, so I buy cheap, crappy Tupperware. Don't microwave things in cheap, crappy Tupperware. Put it on a plate, then microwave it.
And also sometimes plastic will melt
Yeah,
in the microwave.
exactly. Viruses and bacteria, so infections, can cause cancers. They can also cause other diseases, keep in mind, but they can also cause cancers. Certain viruses act on your cells in such a way that they damage the DNA and cause cancers. Probably most of the people in this room have received an HPV vaccine. What's HPV? Yes. Can confirm. Human papilloma virus. HPV is a virus that is transmitted not only, but primarily is transmitted sexually. In my generation, it's estimated that about 70% of people carry the HPV virus because it was something that wasn't well understood or well known about and is very, very, very easily passed on through sexual contact. One of the reasons it wasn't well known about is because it doesn't have any immediate effects. It's not like other sexually transmitted infections that have obvious and discomfortable and whatever signs. You can live your whole life carrying HPV and have no idea that you carry HPV. And specifically for men, there tend to be no long-term health outcomes. There's some evidence of slightly elevated risks of penile cancer, which is not something you want, or testicular cancer, but at relatively low rates. But in women, having HPV is associated with like a 400% increase in rates of uterine cancers and ovarian cancers, which are often life-threatening. And so we vaccinate people so that they won't get the HPV virus, not because the HPV virus itself is dangerous. It's not like HIV or these other ones that causes immediate health outcomes, but because they can be cancer-causing in the long run. And then for a long time, there was sort of pushback against that. You know, new vaccines make people nervous, which is understandable, right? You can imagine being told, we've got a new medicine and we want to give it to your children. People are cautious about that. But it's been well established as safe. And we understand that, you know, the risk of that is much, much, much smaller than the risk of people developing uterine cancers and vaginal cancers. Which again relates to lifestyle choices as well, right? Like, obviously, if you aren't vaccinated for HPV, the number of sexual partners you have is going to increase or decrease your risk of contracting, you know, that disease, just like any other sexually transmitted infection. What else can cause them? This is the kind of scary one. Random mutations. In other words, devoid of any of those other things, sometimes cancers just happen randomly. Because the machinery whose job it is to run your cells, every once in a while, it malfunctions and it just behaves wrong. And so a healthy cell can turn into a cancerous cell, even without any of these things, though all of these things increase the risk of that happening. So, with all of that, what's a cell to do? Because left to itself, we'll talk about what's called the prognosis, the natural history of a disease. But if you develop cancer and your cells begin to reproduce out of control, eventually you'll have a big mass of cells. What do we call that big mass of cells? We'll talk about this in a minute, but you probably know the word. What do they look for when somebody has cancer? They look to see if they have a tumor. That's right, a tumor. By the way, there are other things that can cause a big mass of cells that aren't cancer. So if you have a mass of cells, if you have a lump somewhere, it doesn't necessarily mean it's cancer. It could be other things that are causing cells to grow out of control or that are causing the cells that you have to take on big water mass or something and sort of expand. So not every mass of cells is a cancerous tumor, but some are. And once that happens, those can then begin to interfere with your body's proper functioning, and that can eventually lead to sickness and to death. And without some sort of treatment, cancer is very deadly. Now, having said that, cancer actually happens all the time in your body, or I should say individual cells become cancerous, and the cell has a plan. And there's two things to note here. And I want to show you, what is it here? Okay, so proto-oncogenes, this sounds here. But one thing to note, when you see the prefix onco, that refers to cancer. And so I had a diagram of that I wanted to show you. So a doctor who treats cancer is called an oncologist. That's right. And like the ward of the hospital that you go to is the oncology ward, right? Where you would get cancer screening and things like that done. So here's the deal. These cells that regulate mitotic division, so mitosis, in the body under normal conditions. And it is mutation of these cells is especially dangerous for risk of cancer. Does that make sense? And all of your tissues have these sorts of things. We call them proto-oncogenes, and these are cells that regulate mitotic divisions in the body, and mutation of these cells is especially dangerous for risk of cancer. And so there was a nice table. I'm going to come back to this, I promise. So don't stress. Coming right back. Where was the Wikipedia entry? That's the diagram I want. Can I have it? Give me that diagram. Oh, it won't give me that diagram. Darn it. Anyway, what I wanted to show you... is that like there's a variety of these types of cells that normally regulate the mitosis in each of our tissues. So for each kind of tissue that can become cancerous, there's these cells that normally are there regulating the reproduction of the cell. And it is when those ones are damaged that we get dangerous. So once mutated, we refer to these as oncogenes. So once mutated, we refer to them as oncogenes. Yes, that's risk. I'm sorry. I will endeavor to be neater. How's that? Now, interestingly, the body has evolved to handle this. We actually have a class of things called tumor suppressor genes. And these genes are designed to detect mutations that could cause mutations that are dangerous. And cause cell apoptosis, which is a ridiculous sounding word, I think. But apoptosis is programmed cell death. So what that means is that a tumor suppressor gene's job is to see if something has gone wrong with the cell, and if it has, to say, sorry cell, you're done. Right? And because you have hundreds of trillions of cells, if your body has to destroy one of its own cells, right, that's okay. It can just be replaced. So the goal of the tumor suppressor gene is to destroy the cell, to destroy itself if it detects that damage has occurred. So this prevents cells from becoming cancerous or from reproducing when mutated if it's working properly. Now that means that for cancer to take place, the tumor suppressor genes either need to not function, not be able to keep up, or need to be damaged themselves. But damage to these genes results in a cell that doesn't regulate its mitotic division properly. You don't have to know the ins and outs and details of this. We haven't really studied genetics yet. So you don't have to know how it is that a gene controls something in the cell yet. Just understand the basic idea, which is that there's certain types of cells that are particularly prone to becoming cancerous, and they do in fact have mechanisms to try to prevent that. But like anything else, those mechanisms don't work perfectly. Without some sort of mechanism to prevent that, cancers would be developing all the time. You are so big that with hundreds of trillions of cells, one of them is going to go wrong at a pretty regular rate. So this body does have systems in place to prevent that. And part of the current field of cancer treatment, right now we tend to have, even though they are much more sophisticated than they used to be, our approach to dealing with cancer is still basically killing cells from the outside. Radiation therapy, where they use high energy radiation to kill tumors. Chemotherapy, which if you've known anyone going through, is horrifying. It's really awful because they have to take chemicals that are designed to kill those cancerous cells, but it also damages the rest of the body, right? And work is being done to see, are there ways to prevent cancer or treat cancer that involves strengthening the things the body already does instead of just these tools that are sort of weapons. But this stuff, this hits home very close to home to me, right? Like I've lost my grandparents in the past couple of years to cancer, and then like my dad is kind of going through it right now too. And the cancer treatments we have, we'll talk about in a minute, but they're still they're much more effective than they used to be, but they're still not perfectly effective. And B, they can be pretty awful to watch somebody go through and somebody be treated with. The characteristics of cancer cells, they grow very quickly. As such, they remain very simple and unspecialized. And they mostly, and this is the one kind of piece of good news, stick together in large masses called tumors. That last piece is actually very much a blessing, because if all of the cancerous cells have indeed stuck together in one mass called a tumor, then a highly trained surgeon can do what? Sorry? Remove it. That's right. So this is actually a very good thing if cancer is caught early. If cancer is caught early, usually the cells that are cancerous are all stuck together in this mass called a tumor. And with modern medicine, we can go in and we can often either kill that tumor using radiation or with chemical treatments, or if it's very early on, simply remove it. A couple of things to note. The first is that cancer cells grow at a really rapid rate. And this necessitates a high level of nutrient intake for these cells. Does anyone know what the word cancer means? It's weird what it means. The Latin word. If you're born between June 21st and July 21st, your zodiac sign is actually Cancer, right? It's kind of weird. It's a crab. Cancer is the Latin word for crab. Why in the world did they name this disease crab, which is literally what it means? Well, that's different. That would be pubic lice, which is not what we're talking about here. Why? And the answer is that when doctors first started, and like early, we're talking hundreds of years, thousands of years ago, when doctors would look at cancerous tissue, you get the tumors themselves, which are these large round masses, and then blood vessels that kind of looked like the legs of a crab, which is where that name comes from. But this is important. If cells are going to grow and reproduce at a massive rate, they're going to need a lot of nutrients to do so, right? It takes nutrients to grow and reproduce. And in our body, how do we get nutrients to places? All through your body. How do we move nutrients around? It's like a big highway system for your body. In your blood. And that's in your veins and arteries and capillaries, blood vessels. So, tumors, as they grow, need large volumes of blood to supply nutrients. New blood vessels form and grow towards tumors. Oh, and is spelled with a D, not with a G. In a process called angiogenesis. Which sounds, which sounds very fancy, but angio just refers to blood vessels. And Genesis, first book of the Bible, what does Genesis mean? Sorry? Genesis means creation, right? The reason the first book of the Bible is called the book of Genesis is because it's the book of creation. It tells the Christian creation story, right? So angiogenesis just means the creation of blood vessels. So if you speak Latin, science words are never complicated. What's the process of making new blood vessels? Oh, why it's called blood vessel creation, right? But because it's Latin, it sounds fancy. These blood vessels give tumors the quote-unquote crab-like look. That led to the name cancer. Because cancer is Latin for crab. I always thought, what an unfortunate thing for your zodiac sign to be Cancer. My buddy Jay is always like, that's just your mom, yeah. Your sister, yeah. It feels like we should change the name on that one. Don't you think? Sure, so why not change it to like, I don't know, the crab. Or I don't know, Carly. That's better, right? Right? Gemini, Aries, Sagittarius, Carly, right? Like, sorry? You're a Sagittarius? What month is that? November. Well, it's always like the 21st, right? It's always that. Why is that? Do you know why? It's because where we start our months is actually very poorly chosen. The major kind of dates where the sun lines up with things always land on like the 20th or the 21st in a year. So that should be like our first, like really, it would make sense for December 21st to actually be like the last day of the year because it's the shortest day of the year. Or maybe you could have like June 21st being the start of the year every year because that's always the longest day of the year. 20th, 21st, maybe 22nd sometimes. But instead, yeah, our things are all badly out of line, badly lined up. But that's okay. That's just how it is. Okay, now we said that the fact that they stay together in these tumors is a good thing because it lets them be surgically removed. What is the danger as a tumor grows and starts to attract more and more blood vessels to it? What is the danger there? What did we say the purpose of the blood in general is? Sorry? To move things. Ideally, to move nutrients, to move oxygen. What is the problem when you have a massive lump of cells constantly being made, and now we've brought a bunch of superhighways to it? What's the danger? And this is always the danger with cancer. Yeah. If one of the cells from that tumor makes its way into the blood vessel, what can it do? Well, it can then travel in the blood, and in the blood, where could it potentially go? To the heart, but to the brain, to the lungs, to anywhere. That's the danger. Which is, so my dad has had cancer twice, for example. He's had lung cancer, which makes sense, he was a smoker, and he's had liver cancer, which makes sense, he was an alcoholic. And so the first time he got lung cancer, it was lung cancer. It was cancer that started in his lungs. He actually had that tumor removed, and he was in remission, and he was great. The second time he got lung cancer, it actually wasn't lung cancer. When they tested the cancer in his lungs, it wasn't lung cells, it was liver cells. His liver cancer had spread, which means that the tumor in his liver, which was also under control and was shrinking, and he was in good bill of health for, he'd stopped drinking 20 years ago, and he sort of had his stuff figured out. But in the process of being treated, some of the cells from that tumor made its way into his blood and made its way to his lungs and implanted and developed there. And that is now inoperable. Instead of being one tumor, it's spread all throughout. And that's simply too much to treat. So the danger, we want to catch cancer before that can happen. That's very important. That's why early detection is important. Which is why when women reach a certain age, they're told they should start doing breast exams to make sure they don't develop breast cancers. Which is why if you have a spot on your skin that looks like it's not normally there and meets certain criteria, they tell you to go to a doctor. Which is why men are supposed to start doing self-exams for testicular cancer at a certain age. And I'm about a year away from having to do this, you're supposed to go start getting your prostate checked once every few years. Yay. No, good fun. But because early detection means that cancers can be removed before they spread. And it is the spreading of cancer that is truly where things become inoperable, where they become real problems. So, if cancer cells enter the bloodstream, which again, as the tumor grows, becomes more and more likely, they can move throughout the body and implant elsewhere. Once they do so, they can begin growing in this new location. This process is called, and this is such a brutal word, metastasis or metastasis. So we talk about cancer metastasizing. Boy, that's a terrible word. Stasis means to stay in place. Meta means like sort of across the whole body. So it's a weird word. I've never quite understood why it's called that, but there it is. This process is called metastasis or metastasis. So we say that a cancer has metastasized. I really struggle to say that word. I always really have to warm up on it. But there you go. It's one of many reasons I'd make a poor doctor. Also my gross incompetence. But that's neither here nor there. Sorry? Yeah, right? Oh, looks very weird. On the next page, there's a diagram of that. So the example they use here is prostate cancer. They always say that more people die with prostate cancer than of prostate cancer. It tends to be for most people that if they develop a tumor in the prostate, the recommended treatment is to take some drugs that sort of keep the tumor from growing quickly and just to keep an eye on it. But one of the things they have to watch out for, again, is that when a tumor forms, as it starts to get bigger, it's going to start attracting blood vessels. And if it starts attracting blood vessels, it's possible that the tumor gets so big that it makes its way to the primary blood vessel in the area. And if it does that, cells can enter the blood vessel, at which point they can move somewhere else, right? So if those cells are able to make it into the blood vessel, we call that intravasation. Intra, inside, vasation, the vasculature of the blood vessel, so going into the blood vessel. If the cell is able to intravasitize, if it undergoes intravasation, then it can move anywhere in the body. Your blood circulates through your body all day, every day. And so in this particular example, they say, well, it could end up leaving the blood vessel, extravasation, intra, inside, extra, outside. It can leave the blood vessel, in this example, say in a bone. And you could develop a colony there and a new tumor. And we would say that this cancer, this prostate cancer, had metastasized into the bone tissue, bone metastasis. And of course, if they find a tumor, that's what they'll test. So for example, there are actually cases where the original cancer goes undetected. They'll find a tumor somewhere else. And when they analyze the cells, do you know what they call it when they take some cells out of the body and analyze them to see if they're cancerous? Call it a biopsy. Have you heard that word before? Biopsy. Sometimes when they do a biopsy, like in my dad's case, they'll discover, oh, this cancer didn't start here. You know, they can tell that by the cell type. These aren't cancerous cells of the bone. These are actually cancerous cells of the prostate, even though they're found in your bone. That cancer must have metastasized. And that is always a much more serious thing. Yeah. No, but it's true, right? One of the things we need to know, doctors need to have a really precise language because what they do is so complex, right? So they need to have a language that is very precise and means very specific things. So it's very important that doctors learn this language. At the same time, one of the things I think they could do a much better job teaching doctors is to then speak to people in a way that they can be understood. I know that for the first few years he was in treatment, my dad would go to his doctor's appointments by himself, and I swear he would come back with crazy ideas, and I'm like, Dad, I'm really confident the doctors would not say that. And my wife's a midwife, she's in medicine, so I finally convinced him. He wouldn't let me come. I'd be like, can I come with you? No, absolutely not. Yeah, stubborn old man, right? But I finally convinced him to take my wife with him, and he likes my wife way better than he likes me, so that's good. So he does. Oh my God, my dad thinks he'll call my dad will call me up and be like, oh, hey, yeah, is Britt there? And I'll be like, oh no, she's out today. He's like, oh, okay. I'm like, oh, what are you calling for? He's like, oh, I'm just I'm doing this renovation job and I just wanted to see if she wanted to come help me. I'm like, I'm free. He's like, it's okay. I'll wait for Britt. See you, Joe. And they'll hang up and I'll be like, did I just get rejected by my own dad in favor of my wife? Kind of hurts my feelings. But anyway, it's what it is. But she would go with him and same thing. She realized he is totally confused about what he should be doing because, again, doctors just speak as though you know what your cardiovascular system is, and as though you know what metastasis is, and as though you know what intravasation is and extravasation, and right, and what a primary tumor is and a secondary tumor, and frankly, you know what your prostate is. I mean, hands up in this room if you have a prostate. Yeah, the men do, the ladies don't, right? If you're biologically male, you have a prostate. It's part of your urogenital system, right? Does anyone know what it does? Anyone? Of course not, right? Like, why would you, right? It has an interesting function. It has an important function, which is in the female urogenital system, they have separate whole systems and tubes for the reproductive organs and for the urination, right? To the outside of the body, right? They have a urethra and a vagina. Men don't. You actually have a single opening, the urethra, and it has to handle the release of both urine when urinating and semen during sexual intercourse, and the prostate's job is to switch between the two, right? That's its job. Okay, now you know. But why would you know that if you've never been taught it, right? So doctors have to keep in mind that people don't necessarily know what all the parts of their body do, right? And how they work. And interacting with the medical, and they're very busy, right? Like, anyone had to go to like the emergency room lately? I don't know. I'll tell you, I hadn't been to the emergency room in years. And I remember like the last time I went to the emergency room was with my grandmother. Like 6 years ago, she had a fall, she broke her hip, and she got seen very quickly. Now, that was a pretty serious thing. Like, she was in pretty bad shape. A few weeks ago, I had to go to the emergency room with my wife, and she had a concussion, but she was like knocked unconscious and bleeding. And like the paramedics took her there in an ambulance. So I kind of had it in my head that we were going to get pretty like swift service. And don't get me wrong, everyone knows incredible. We were in the emergency room for 27 hours in a hallway on a gurney. And there was about 40 people on gurneys in a hallway. That's crazy. Like, that's a wild system. And then I have a friend, my high school principal actually, is dying. He has cancer and he's sort of on his last legs. And I've been going to visit him and see how he's doing. He's an amazing guy. And, sit and chat with him and tell him, we share stories and whatever. I went like probably 4 times in 2 months. And there was this lady on a gurney in the hallway, had cancer. And she's been on a gurney in a hallway for months. It's crazy, right? Like, our medical system is stretched thin, very, very thin. Yeah, can you imagine? Yes, all day, every day. Can you imagine? It's wild. It's horrible. It's horrifying, right? Like, we obviously need more beds. We need more rooms. We need more doctors. We need more nurses. By the way, study biology. Become a doctor. Become a nurse. These things are very important. They're very needed. We need more of them. But so you can imagine that when doctors are talking to you, they are thinking about the next 40 patients they have to talk to. They're just getting the information out to you. And in the meantime, if you don't know what they're saying, that can be a scary thing, right? I think so. We name cancer after the location of the growth, and I should add here, of the primary tumor, where it started. So we name cancers for the place they grow. So some of them are just very easy. For example, when tumors develop in the breast, we call that breast cancer. That one's pretty obvious, right? Some are not as obvious. For example, if somebody develops, again, some are more obvious. Pancreas, we would call that pancreatic cancer, right? So that's again pretty obvious. But back to this medical thing that you have to be aware of, some of these things are not so obvious. Leukemia. Where's leukemia located? But just like here's an example. It's a good guess, but here's an example of that medical information, right? You may know somebody who has leukemia. You may know somebody who has leukemia who it takes a while for them to know where their cancer is, because that name is not like breast cancer, which is pretty obvious, or pancreatic cancer, or whatever. Leukemia would be located where? The white blood cells.
White blood cells.
Yeah, you got it. That was good. If nobody tells you that, if you don't look it up, you wouldn't know that, right?
I believe anemia means presence of blood.
Yeah, anemia in general can look like a lot. Yeah, it looks like a lot of things. Sorry, another one's. Cervical cancer is where? Which is where? It's in the female reproductive system, right? Specifically the cervix. I'm trying to think of other ones that have odd or confusing names. I had a cheat sheet for this, and I left it on my desk at home. And now, of course, it's immediately leaving me. But I just wanted to mention some of the ones that might not be immediately... one of them I had for sure. Melanoma. A terrible name. And more often we'll just use the generic name now. But where would melanoma be found? It is. Very good. Skin cancer. Melanin is the pigment that's in your skin, so I guess that kind of makes sense, but even still. Or I should just say it's skin. Oh, I had another one that was commonly confusing, and now I'm so ashamed. I'll think of one later. But be aware that if you hear of a type of cancer and you're not sure what the name means, the name will be telling you where it formed. Does that make sense? And so that's what you could look up. So if you learned, for example, that you had hepatic cancer, does anyone know what HEPA as a prefix refers to in the body? It's the organ responsible for blood filtration. Kidneys, correct. So yeah. Now, risk factors. There are a number of risk factors. One is sort of exercise versus sedentary. The word sedentary is just the opposite of active. I should say active versus sedentary. That would have been... for whatever reason, it is well understood that people who are regularly active have much lower cancer rates than people who are regularly sedentary. Sedentary means things that involve a lot of sitting. So if you're somebody who's a jogger and a hiker and you love to ride your bike, that is going to be associated with a lower lifetime risk of cancer than if you're somebody who's into video games or sitting on a couch reading or whatever. Things that are physically active for whatever reason, and it's not entirely understood why, are associated with lower cancer rates. So an active lifestyle is associated with lower cancer rates. I don't care for this suggestion, but maybe. I definitely care. I don't care for the accusation. I definitely care if you get cancer. I hope that. Unfortunately, roughly what percentage of Canadians get cancer in their lifetime?
41.
Yeah, around about half, roughly. Most people of whom survive that, because most cancers are now treatable, but many of whom don't. So, unfortunately, most of us, almost all of us will either get cancer or have somebody we love get cancer in life. You may well already have gone through that. And if so, A, I'm sorry. And B, that's why it's so important that we fund science and we fund research. Because in 2025, people survive cancers that were considered deadly in just as recently as 2010. Our ability to treat things is improving and getting better. And provided we keep doing research and we keep learning, that should continue to be true. So science is important. What are other major risk factors for cancer? Dietary. Various different cancers, dietary choices are related to them. So dietary, and related to that, and one I have to be mindful of, and obesity, right? I'm clinically obese, and that is associated with very elevated risks of many cancers. Substance use. Anything you smoke is associated with incredibly elevated risks of lung cancers, throat cancers, mouth cancers. Whatever that may be, whether it's a pipe, whether it's a cigar, whether it's marijuana, whether it's tobacco, whatever it is. Vaping, because of nicotine, is associated with elevated risks of cancer. Alcohol use is associated with incredibly elevated rates of cancer. I don't know about a lot of illicit narcotics, to be honest. I think the dangers with them, the more dangerous the narcotic, the less cancer ends up being the concern, because, of course, There's other immediate concerns, overdose, things like that. So I don't know. But be mindful that, and life is a trade-off, you know? You tell people that even just the moderate consumption of alcohol, a couple drinks a week, is associated with something like a 20 or 30% elevated risk of developing cancers in their lifetime. People may say, that's a trade-off I'm willing to take. People who are habitual drinkers, binge drinkers, that's now associated with something like a 200% elevated risk of developing cancers. That may be something that people still say, yeah, I'm willing to deal with that, but you should at least be aware, be mindful of it. Likewise with smoking, you know? When I turn 75, boy, am I going to start smoking. Oh, yeah. Come on. Oh, sure. Well, we're all going to die, right? I figured by then, my heart's going to take me out long before the cancer gets me at that point. But joking aside, in all seriousness, if a 75-year-old takes up smoking, that is unlikely to be the thing that kills them. If a 15-year-old takes up smoking, it is very likely to be the thing that kills you in the end. That's something to think about. And let me tell you something else. Long before it kills you, you can end up like my Uncle Jack, who spent the last 20 years of his life. A guy used to be an amazing athlete and an active guy, and has spent 20 years of his life carting around an oxygen tank with a mask that he has to wear because he can barely breathe, right? Something to be mindful of. What else? Genetics. You can get genetic testing done that will show you what cancers you may be of elevated risks for. Breast cancer is a big one. We know there's a large genetic component to breast cancer. Some women have a set of genes that results in you being much more likely to have tumor growth in the breast tissue than other women do. That is something they can test for. And if they test for it and they know that, right now there's nothing we do to stop it, but it means that somebody who knows they're at that elevated risk should be getting tested and screened more regularly and be more mindful than someone else.
Caesar salad for $3, and today's main entree is buffalo mac and cheese for $4, or a hot dog with fry with a salad for $6. We'll also be having poutine for $6, and hot dogs are $4 each.
Ooh, that sounds good.
Having pizza, a slice costs $2 each, and remember, Eagles, we always have French fries. A small being $2.50 and a large being $4. That's on today's cafeteria menu.
Did the price go up? Is that a new price? That's unfortunate.
For today, including our iced coffee, cupcakes, and cookies with banana bread for $1 each.
I know we're doing prom, and the venue, it's $1 more a person for food this year. It's like, oh, the me, well, there you go. Never mind, we fundraised for those. We did a big old event. Big old event. There you go. You think my lights did it? Gary the Spotlight? I named him Gary. Yeah. He's hanging in the calf now. He was here. Now he's hanging in the calf. Environmental exposure is a big one, especially at work. There are very strict rules now about what chemicals you can be exposed to at work. It's gotten a lot better than it used to be. It is still the case that people who work in various industries get cancer at a much higher rate. People who work in the petrochemical industry get cancer rates much higher. Interestingly, we don't know exactly why. The Niagara region has incredibly high cancer rates relative to other places. Hamilton has very high cancer rates. Notably, big factory town, right, where there's shooting stuff into the air constantly. So these are some of the risk factors. We should say there's many more. Treatment for cancer. What I want you to look up, actually, is your homework, is I want you to look online and fill these in, just with quick descriptions. Quick descriptions in your own words, both for the treatments, and the stages. Some of these are pretty obvious.
Wait, can you list what again? Quick descriptions of what?
In your own words, of the treatments and of the stages of cancer. Yeah. I want you to tell me when we say that they can treat cancer by surgery, what is the surgery? What do they do? When we say that you can treat cancer by radiation therapy, what does that mean? What is chemotherapy? What's immunotherapy? What is targeted therapy? What is hormone therapy? So, and again, I didn't leave you a big space. So am I expecting you to write a paragraph there? No.